Hello, everybody.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. Back to you today with another great episode. Today we're going to be talking about quite a controversial topic. That topic is the Hyperloop. A lot of people are saying it is Vapourware, and to some extent some of the projects are Vapourware, but I'm going to tell you about the good, the bad and the ugly and really break it down for you today. So here's the presentation. Okay, so this is an interesting topic. There's a lot to talk about. Let's get right into it. So, as you can see, the depiction of the Hyperloop is very similar in a way to how we run trains today. However, there are some major differences. And this is what brings us in with the conflict with the train lines, the railways, and various other local transport operators. So before we get going, thank you for tuning in. Please like and subscribe to the channel if you've not already done so, and please comment on the video. We do very much appreciate all comments, and hopefully you can provide some interesting kind of feedback on the video, as it were. So it's time we talked about the Hyperloop. Been a long while, not talked about it for quite a bit, and the reason being is there's just not really much been going on. There's been a lot of kind of technological kind of adaptation and breakthroughs and kind of progress in the background, and that's wonderful. But in terms of actually building projects or actually kind of building, your models and kind of adapting existing kind of systems that have already been built, not much has really been going on. So it's difficult to talk about something when not much has happened. So that's kind of the main reason that the Boring Company will never build a Hyperloop. That's not the kind of mission statement of the company. However, they may provide infrastructure that could be used for a Hyperloop in the future. We're talking about sort of the long term, if not very long term. Companies will seek to partner with the Boring Company for tunnelling stretches. Ultimately, if the Boring Company can achieve 100 meters per day with the TBM proof rock, then obviously that's going to be interesting for certain companies in terms of partnering up. Why build the Hyperloop and who will fund these large projects? These are questions that remain very much unanswered, as it were. So hopefully we can try and answer that today. Also, do I support the startups attempting to perfect the Hyperloop? Absolutely. That is what they are at the moment. They're startups. They're not proper kind of fully funded, profit making, or even attempting to turn over money companies at the moment. They're purely just startups, and that's why we're kind of stuck at the very kind of infancy of this industry. It's not progressing as quickly as people would have liked, but ultimately that's what happens. It takes time. Right, who are the key players? Who's kind of driving this technology forward, as it were? Well, there's kind of 6 key players. Hyperloop TT and Virgin Hyperloop One are kind of the main players that are getting the majority of the big proposals at this moment in time. However, there are some other people that are making a good kind of a contribution to this space. Transport Inc., Zeleros, Hart Hyperloop, and Nevomo, who have kind of been spun out from Poland Hyperloop. So these companies are all looking to develop their own technologies and develop their own systems. They have yet to kind of agree to some kind of standardization, which is quite worrying, but I think that is progressing in the background. What actually is the Hyperloop? I'm sure you already know all this, but we'll just go over it now for potentially people that haven't heard of the Hyperloop, if you are one of those. So it's a partially evacuated tube, but it's not a vacuum. People saying it is a vacuum are essentially lying to you because they're not telling you the truth. It is not even that close to a vacuum. It's 2.5 psi, which is just over 0.1 bar. So it's a very low pressure environment, the same kind of environment that like a jumbo jet would be operating at, high up in the atmosphere. you've got a cruising speed of around 620 miles per hour. They don't necessarily need to go at those speeds, but it looks like that's what they're aiming for, 1,000 kilometers per hour. They use linear induction motors. That's kind of the key kind of technology that they're implementing in the system that's going to differentiate them from the railways, and that they've got a much more efficient means of kind of putting the power down, as it were, into moving the vehicle forward. Track switching requires 0 moving parts, so you don't actually have a physical rail. It bears more resemblance to kind of a maglev system that you would have seen 20-30 years ago. Standardization of designs has yet to occur. It's a big problem because a lot of different operators are proposing different sizes of tubes. They're proposing different kind of methods of kind of pushing the vehicle forward in terms of powers, in terms of layouts and designs. So the fact that that's all very, very different is quite worrying, really, because you could end up essentially with different systems running alongside each other that are not interoperable. So there has been an effort by 4 companies, Hertz, Zeleros and Transpod and Novomo, to kind of agree to some standardization. I think they have agreed on certain parts, but they've not come to the end conclusion of kind of a finished design, as it were. Hopefully that progresses in the next 2 years or so. Complex expansion joints are necessary every 25 meters. As you know, this worries me quite greatly. In terms of me thinking how you're going to build and maintain this, having so many expansion joints over a system that could be potentially over 1,000 miles long, you open yourself up for issues on that one. And your typical, let me just pull out the pen. There you go, green. An expansion joint will look similar to this. Much bigger version. It looks more like a bellows, as it were, that you might see in some kind of power station. These things potentially could be very expensive over a very long network, and ultimately at the end of their life they will be expensive to maintain. Okay, so just to put that out there, as you may remember, I did propose a solution to removing the vast majority of expansion joints. I proposed this tube within a tube system, which it looks like someone else here, I forget which company it is that produced this drawing, has kind of introduced this one. It looks very, very similar to my design. You've obviously got your castellated steel ring beams. Let me just correct something. Yeah, so as you can see, this particular design is very useful because it eliminates any thermal expansion in the kind of inner tube, resulting in this being one solid piece of steel that you weld together in various kind of segments. You don't need any expansion joints, and this kind of outer layer is cooled, conditioned. And then you would have some expansion joints in the 6mm external layer, but you could use kind of off-the-shelf components for that, which would be much more kind of cost-effective, as it were. Okay, so what are the advantages over the railways and airlines? Yes, some railways use electrical propulsion, but they are not zero emission. They just buy the energy from any source, the cheapest source. But the Hyperloop will be zero emission from day one. That will be kind of one of the most important goals, as it were. Modern, adaptable design. When you start from scratch, it's so much easier to do something, because when you have to work to existing kind of design kind of principles, it constrains you. And being able to start from scratch and having the freedom to modify and change things at certain parts of a project, this really makes things a lot easier. So having that blank sheet of paper is definitely very useful. Low energy usage per pod per mile, extremely low energy usage. I'll show you in a moment a diagram that kind of illustrates this, but you're talking 60 to 70% less energy usage per pod per mile or even better, per passenger per mile. That'd probably be a better metric to use. Achieves very high speeds. We're talking close to 600 miles per hour. They don't necessarily need to do those speeds. They could actually improve the efficiency by running at slightly slower speeds, maybe sort of around 450 to 500 miles per hour. And that thus leads to shorter journey times. Minimal noise pollution. So, if you live opposite an airport, or even within 5 or 6 miles of an airport, you know that it's an extremely noisy environment. Train stations are the same. If you live near a railway lines are running everywhere. Ultimately, you're going to hear those trains all the time. With a Hyperloop, that's not an issue. You know, it's in a vacuum. It's encased. You're not going to hear anything. You could argue maybe it's more of a visual issue, but I think that noise pollution is an important thing that needs consideration. Absolutely. So, what kind of the costs? When people say a benefit of Hyperloop is the cost per mile, I'm very skeptical about that. I'm very skeptical because I believe the cost per mile of a Hyperloop it is either almost exactly the same as a high-speed rail line, or maybe 5 to 10% more. I've not seen any evidence yet that kind of illustrates it's going to be cheaper per mile, especially when you look at systems in China and South Korea and other countries like Taiwan who have built a bit of high-speed rail as well. You know, are they going to be able to compete on cost? It's difficult to say. And that's kind of out to be proved. Also, you'll know that Japan are developing their own maglev system, so they've decided that Hyperloop is not the future and that they're going to develop a maglev system which has got speeds in and around 300 miles per hour, which is still very, very good, but it's going to cost a lot of money. And the question is, could you not do the same with maglev and it would be easier to build? Comparable build speeds, I think building a Hyperloop system, if you develop it with a blank sheet of paper, maybe you can kind of develop a construction methodology which is a bit more prefabricated, but still, you know, in terms of build speeds in comparison to high-speed rail and maglev, it's going to be around the same. So cost and build speeds are not advantages of this system. In my opinion, I've not seen the evidence that supports that. Yeah. So the 3 core issues holding back Hyperloop construction: cost per mile, entrenched interest groups, technology is not yet mature, financial requirements, and lacks political support. So I think the actual cost per mile of a Hyperloop is in the region of $40 to $65 million per mile. I've not seen any evidence that suggests that it's going to be less than that without some considerable breakthroughs in kind of tunnel technology. Maybe if they put a very, very large proportion of it underground. It doesn't look like any of them are approaching it in that way, by the way. It looks to me as if they're going to put a very, very large proportion of it above ground, if not in cuttings. Potentially some of it will be cut and cover as well. So, you know, costs will be quite high for Hyperloop. Anyone saying otherwise is just hoping for the best, basically. Interest groups, obviously in the airlines and the railways, they're going to oppose this at every single possible opportunity. So that will kind of hold it back getting through regulatory approval and planning approval. And the kind of key one is the technology is not yet mature. We've not seen this demonstrated yet. We've not seen any projects run successfully. We've seen a lot of people switching and changing designs, and ultimately that's the evolution of the design, and that's good because they're coming to the conclusion about what they actually need the design to achieve. Improve kind of the performance characteristics of each design, but because they're doing that, it is not yet mature, this design, and no one's going to take that on until they get to that stage where they've kind of got close to 98%, 99% perfect. Financial requirements, these projects, like I say, because of the cost per mile, it's going to be a very, very big expenditure. Ultimately, who is going to pay for that? These startups are not going to pay for it. Government's going to pay for it at this moment in time. I doubt governments are going to pay for a project that has not got a track record. So the kind of the finances of finance, actually kind of finding the money and actually implementing that money efficiently is going to be difficult. And there's a lack of political support as well. So there's not many politicians going out there saying, hey, we should be building hyperloops, don't build high-speed rail lines. That's kind of not really happening there. So it's a difficult one. All those areas could potentially change in the future, but it's going to take a long time. So what do I think will happen in the future? This is prediction time. So 2022 to 2028, I anticipate very, very little is going to change. I think we're going to keep going down the same line where people are working on the technology, they're perfecting it, they're building these kind of test areas like Hart are doing, and they're kind of experimenting and doing the R&D necessary to make this technology work. And hopefully during that time, all the companies, or the vast majority of the companies, at least 7 of them, come together and say, hey, we're going to focus on this kind of one standardized design, and that just makes things a lot easier for everyone to kind of progress forward. This is an expansion joint, by the way, if you want to have a look at what an actual expansion joint will look like. It's quite a complex piece of equipment to both install and maintain, and these things do need replacing over time as well. So 2029 to 2035, I think we'll see a lot of consolidation within the industry. I think we'll see a lot of the European companies merge together. I think in the US as well, we'll see a lot of these research kind of companies. Well, I think they will fall away, and those people that have worked there will come and work for the bigger companies, and you'll probably see maybe 2, maybe 3 players in the end, and they'll have a lot more financial clout, and they will have perfected the kind of technology they need at that stage. I think 2036, 2040 is when we'll start to see projects that are going through the planning approval stage. They will begin to start. We might see the first ever finished Hyperloop project come online. I don't anticipate that it will be doing sort of 500-600 miles per hour. I anticipate it'll be closer to 400 miles per hour, and it'll have a throughput maybe of 10 to 15,000 passengers per hour, but it'll still be going at a fairly high speed, close to 400 miles per hour. 2041 to 2050 is when we really start to see progress. Major schemes will be built in the North America, Europe, potentially Asia and the Middle East. We'll start to see maybe talks about various different projects interlinking between each other. Governments will become more involved, and they will start to incentivize people investing in this space. Between 2051 and 2060, again, we'll start to see this expanded down into regions that otherwise didn't have the Hyperloop. South America, potentially Africa will get its own system. Places like Australia, maybe Australia will come a little bit earlier than that, maybe between 2041 and 2050. But at that point, the designs will be standardized. We might even see further consolidation. We might see maybe it go from 3 companies to 2, maybe even down to 1 company. Who knows? We might see other companies join the fray as well. We might see the kind of big 3 merge together. We might see 2 other companies, appear, maybe just 1 company. So those are my kind of predictions. As you can see, the timeline is quite stretched out. I don't anticipate much going on over the next 6 years. I really, really don't. And that's just the God honest truth. I expect that we will still see people building maglev systems in Japan. I don't think the Japanese will change. I think they'll just keep going with that. There's nothing wrong with a 300 mile per hour system. That's very, very effective at moving people, and we'll still see high-speed rail lines built in places like the European Union and China. China's invested a lot of money in high-speed rail, so I don't expect them to take on Hyperloop anytime soon. Although they might move to maglev. So what is the conclusion? Yes, there are a lot of advantages to Hyperloop, but they've not quite got there yet. There's many hurdles to overcome, especially the financial hurdles. They need to prove that this works. They need to standardize the design. They need to perfect the technology. As you can see, in terms of efficiency, energy consumption, watt hours per passenger per kilometre, is 116 for a high-speed train. For Hyperloop, it's just 40. It's a lot less. For an airline, it's 515 watt hours per passenger per kilometre. It's a lot. We need to get rid of this, just cut it out totally, and replace it with this. But we also probably need to expand this as well, high-speed trains. And remember, building this infrastructure is going to take a lot of time, it's going to take a lot of capital, and it's not going to be cheap. And it may be that the costs are just too much to bear for many countries, and they decide not to go down the Hyperloop route. And remember, when people propose stations like this is not cheap. This is like $400 million worth at the bare minimum. Consider all this land that's around here as well. All this land here is required as well for whatever park they're building. Plus, this incredible structure is not going to be a cheap option. So, ultimately, it's very, very expensive to build, and not a lot's going to happen over the next 6 years or so. But the Boring Company has a part to play in this. If it can reduce the costs and speed of, and increase the speed of tunnelling, then ultimately it can take advantage of this industry, go in there, help these companies build out these infrastructure projects for a reasonable price, and that will give them the money that they need to also expand their loop system, which potentially someday might be tapping into stations just like this. Okay, well, I hope you enjoyed the presentation, despite some of the technical faults we've had today. But hey, we will fix it. Please consider supporting me on Twitter, Patreon as well for $2 a month, and joining me on Discord. Okay, well, thanks to all my Patreons. Many of you are doing a great job at supporting me, helping me expand the channel. And yeah, I really do appreciate all that. Thank you very much. Okay, guys, well, thanks for joining me. I hope you enjoyed the video, and I hope I will see you on the next one. And remember, guys, don't be boring. I will see you on the next one. Goodbye.
It's time to kick ass and chew bubble gum. I'm all out of gum.